Okay. Here, it's just like the second method that I used in differentiating in the previous problems. So if you want to work on number 41, suppose we want to work on number 41, we've got y is equal to sine squared of pi t minus 2. So y is a function of t. So if I want to take the derivative, therefore, I look at the big picture. The big picture is that there's a sine function that was squared. So we can rewrite this as sine of pi t minus 2. Whole thing was raised to the second power. So on the outside working in, we apply the derivative rule, or the power rule, which means I bring down 2, and I'll take sine of pi t minus 2 raised to the first power. And then go on the inside, I'm taking now the derivative of sine. So what is the derivative of sine? It's equal to cosine of whatever is evaluated in their function. And then, am I done with my differentiating with respect to t? Not yet. Because so far, we still have to work on the inside of sine. So now we differentiate pi t minus 2. So the derivative of pi t minus 2 is pi. Minus 0, of course, but I'm not going to write that down. So what we've got so far is, let me go ahead and put the constant functions in front. So it's equal to 2 pi times sine of pi t minus 2 times cosine of pi t minus 2. Let's work on number 42. Y is equal to secant squared pi t. Again, the big picture here is that secant was squared. So the first thing we need to do, of course, we can rewrite that as secant of pi t. Whole thing has been squared. So if I want to take the derivative of y with respect to t, I'll look at all the big picture. It's a squared term. So apply the power rule first. So 2 times the secant of pi t. And I don't stop there because now I have to differentiate what was squared. So it's the derivative of secant pi t. And then I don't stop there because secant has an argument other than t. So now I have to differentiate pi t. So what is that? That's equal to 2 secant of pi t. Now I take the derivative of secant, which is secant times tangent, and then the last part would be the derivative of pi t with respect to t, which is just pi. So in the end, what we've got is 2 pi times, we have two expressions of secant multiplied to each other, so that's secant squared pi t times the tangent of pi t. Keep going. Suppose we want to work on number, well, I am not going to work on number 45 because that's your homework, but let me go ahead and show you how to work out, say, number 46. How do we work on number 46? We've got y equal to something that is raised to the 4/3. So it's t to the negative 3/4 times sine of t. Y prime is working on the outside going in. So the outside is a power rule. So we bring down 4/3. So 4/3 times this expression raised to the 4/3 minus 1 times the derivative of the inside. And what is the inside? It's t to the negative 3/4. times sine of t. And then the derivative of whatever was raised to the 4/3. Whatever's inside. Okay, so this is equal to 4/3 sine of, this is equal to 4/3 times t to the negative 3/4 sine of t. 4/3 minus 1 is 1/3. Now, how do we take the derivative of what's inside that was raised to the 4/3? It's a product, so we have to apply the product rule. So first, let's take the derivative of the first term, minus 3/4 t to the minus 3/4 minus 1, okay, multiplied by sine of t. That's the first part. Plus, we take t to the negative 3/4. This time, we multiply by the product of sine t, which is cosine t. And that's equal to 4/3 t to the negative 3/4 sine t, whole thing raised to the 1/3. And if you notice, these actually cancel out each other. Well, no, not really, because it's a sum. So let's just keep going. It'll be negative 3/4 t to the negative, what is minus 3/4 minus 1, that's negative 7/4 sine of t plus t to the negative 3/4 cosine of t. And I think the rest of it is just, I think this should be a final answer. Finding derivative values. For exercise number 65 to 70, we find the value of the composition, the derivative of composition. It's like we're looking at the slope of the composition function, the slope of the line tangent to the composition function at a given value of x. Let's try number 66. Finding derivative values. So let's look at f of g and take its derivative and evaluate it at x equal to negative 1. Now here, I think the first thing we need to do is first let's apply the composition because it'll make it easier. I'll show you why. Our f of u is equal to 1 minus u to the negative 1. And our u is equal to 1 minus x raised to the negative 1. So look at it this way. If I were to apply f of u of x, that is just substituting u here. So in terms of its variable x, so 1 minus, what is u? It's this whole thing. So it's 1 minus x to the negative 1. This is just my u, okay? It's just my u raised to the negative 1. So what do we have? We just have a simple function because this is 1 minus, what is a power raised to another power? You just multiply the exponents. So it's just 1. So that's 1 minus x. So that's equal to 1 minus 1 plus x. So all we have is just the x. So what's the derivative of f with respect to x? It's just 1. Because this is simply saying that f and g are inverses of each other, because if you compose it with each other and you get x, that means they're just inverses of each other. So what is f prime of negative 1? It's just 1. because it's a constant derivative. Okay. Let's look at number 71. Number 71 says here that f prime of 3 is equal to -1 and g prime of 2 is equal to 5 and the value of g at 2 is equal to 3. So the question is, what is y prime of 2? So first of all, y prime at 2, or y prime, is equal to f prime of g times g prime of x. And if we're evaluating at x equal to 2, y prime of 2, that's f prime of g of 2 times g prime of 2. And what is f prime of g of 2? We know that g of 2 is 3, so f prime of 3 is equal to -1. This whole thing is, let me write it down, it's f prime of g of 2 is 3 times g prime of 2. So that's equal to -1, and then g prime of 2 is right there. It's equal to 5. So that's equal to -5. Number 72. What we've got here is r is a sign of the function f. So if I want to take the derivative of r with respect to t, I'll take cosine of f, because that's the derivative of sine, but I don't stop there because this is the derivative of r with respect to f, so I multiply by the derivative of f with respect to t. And then we evaluate at t equal to 0. So r prime of 0 is equal to the cosine of f of 0 times f prime at 0. So what is f of 0? Right here it says that f of 0 is pi over 3. So we're evaluating the cosine of pi over 3 times f prime at 0 is equal to 4. What is the cosine of pi over 3? That's a 60-degree angle, so the cosine is 1/2 times 4. That's equal to 2. And the next thing that we will talk about is derivative as a rate of change, and also the next thing after that would be when is a function not differentiable? In other words, can we always differentiate a function? So I will see you later.